Hello, and welcome to this video tutorial where we will use MindFusion's Java profiler called HyperDebug. The application that we will trace and optimize is a simple one. It goes through the records on the file that you will see at the screen. In each line is the name, age, and profession of a person. The program writes each record in a separate file based on the profession of the person. To make the program slower, we've duplicated a few lines in the file. The program first searches if the given record is already written in the file with the profession and adds a new record only if no record is found. We use file input stream to open the initial file called data.txt. We cycle through all lines and parse the words on each line. After that, we write the name of the person in a file that has the name of their profession and note how many times a record for them is found. Most people are found just once. All of this process is slow and inefficient, and we start HyperDebug to gather initial information about the execution time of each method, number of calls, and more. We start the profiler by double-clicking on its executable jar and open the config dialog. There, we browse to the main class of the file parser application. In this case, we don't have to select a main class, because the only class is the main class. We check the Trace Parameters checkbox to make the tool gather info about the parameters of each method. Then we hit Run. HyperDebug executes the program now, and here it is. It opens the gathered log files and visualizes the traced information. Let's take a look at the JVM total info data. Here we see the name of each method together with the type of its parameters as well as how many times it was called and the total execution time for all calls. We see that 3 methods get called a lot, with the replace selected method being by far the most time-consuming one. The time monitor step confirms this information. Replace selected calls took a lot of time, surpassed only by the main method call. As for the count of calls, all methods except main were called an equal number of times. Knowing all this information, let's get back to our file parser. We delete the parsed files and leave only the initial data file. Let's start HyperDebug once again, this time from scratch, and see the outcome. Now, the method that gets called the most is the main method. Both the time monitor and method data methods confirm this. Let's see what happens in the program methods. The main method calls replace selected, which searches for a line in a file and replaces it with another line if found. The other method is search in file, which returns 1 if a given string is found among the file records. All this is a very slow I/O operation, which we will change. Let's start our optimization by including a hash map. The key will be the profession. The value will be another hash table. It will contain the name of the person together with the number of records for them. This way, any record in the outer hash table represents the data in a single file. Let's edit the main method and make it use the hash map. In the part where we cycle through all records, we check if a key-value pair for the given profession is already present. If so, we get the hash map that contains the records. In it, we check if the name of the person is contained. If yes, we increment its value with 1 to show that we have found another record for them. If a key for this person is not found, we add a record with their name and the value of 1, its first occurrence. Then, we finish the check for the main hash table. If a record for the profession is not present, we add a new key-value pair. The key is the profession, and the value is a new hash table that will hold all people with this profession and the number of records we found for them. Let's add the name of the current person to that map. We can comment the old code now. Now we need to implement the part where we write the records in a file. Let's do it in cycle, where we go through all records in the main hash table. We write each one with the help of a new method called writeToFile. This method takes as an argument the name of the file and the hash map with the file data, that is a key-value pair from the main hash table. Let's use a print writer the way we did until now to write the data into the file. In the comments for the printWriter constructor, we see that if the file does not exist, it will be created, which is exactly what we need. Then we cycle through all values in the data hash table and write the information. Note that we prefer to use for each cycles to traditional for cycles. Now let's delete all files with professions and start the program anew. The time log shows us that execution time has been cut significantly. Here are the new files with the records. Let's delete them. Let's also delete the current log files for HyperDebug and start the application again. We load the main class and tick trace parameters. The program executes faster and the performance progress is easy to spot. We now have only 2 methods, both of which take far less time than the previous set of methods. The method data step shows us that the writeToFile method was called 53 times, which is far less than the previous method counts. The call graph shows us that main calls writeToFile, which takes 127 milliseconds to complete. Main takes 163 milliseconds to execute, which means that besides the writeToFile method, other code does not take much. Here we see the subsequent recordings of the files with the professions. And that's all for now. Thank you for watching, and thank you for your interest in MindFusion developer tools.